Okay, so I drew a little picture for you. Well, I had the computer draw the picture, but so that's basically the area we're looking for. It's from 2 to 4, right? And you have the parabola. Um, so A and B ask us to find just the general left and right hand approximation for n rectangles, meaning at that point you can plug in any number of rectangles, right? And then here, L4 and then R4, that's just try with 4 specific rectangles. Now, do you guys think that would give us a good approximation or a bad one? Pretty bad, right? It's only 4 rectangles. That's not very good. And then we'll find the exact area by doing the limit definition, right? Okay, so we have to find a lot of stuff here. So you guys probably found A is 2 and B is 4, right? And then delta x is B minus A over n, so 2 over n, right? Okay, and then after that we can find x sub I, which would be, remember, it's A plus I delta x, right? Okay, and then then using that, what's f of x sub I? Okay, so let me just plug it in here. So f of x sub I would be 2 plus I times 2 over n squared minus 2 plus I 2 over n and then plus 1. All right, so now you have to be careful here. Yes? No? Yes?
Is I the amount of intervals there are?
No. I is the index. So I tells you which evaluation point you're at. So for example here, yeah, so here I have, this is 2 and then here's 4, right? So this is the area that I'm finding. So depending on how many subintervals I break it up, my interval into, I is the index. So like here, for example, the left end point would be I equals 0 because you're at the point x sub 0. And then the second point would be I would equal to 1 because you're at x sub 1. And then x sub 2 and x sub 3 and x. Does that make sense?
Yes.
So I is the one that's going to go from 0 to n minus 1 or 1 to n when we write it out in some notation. Does that make sense? Yeah. Okay. All right. So now if you simplify this, what do you get? What'd you guys end up with? If you put them in order, how many I squareds? Okay, I'm going to guess you guys got 4 over n squared I squared. Yes?
Yes.
Okay, how many i's? Plus? 6i over n. Okay, what else? Plus 3. Yeah? Raise your hand if that's what you got. Okay, so if you didn't get that, then you have to check your work. All right, now once I have f of x sub I, then I can do L sub n and R sub n, right? So the left-hand approximation, so what is this equal to? So this is going to be the sum from I equals, the left goes from 0 to n minus 1, right? Of, remember, it's f of x sub I times delta x. So what is f of x sub I? Well, it's what I just found, right? 4 over n squared I squared plus 6 over n I plus 3 and then times delta x. What is delta x? 2 over n. Okay. And then, so that's fine. And then what's r sub n then? Yeah, so all this is going to be exactly the same that as left, right? The only difference is that we're going to start at I equals 1, and then we're going to go up to n, right? So the only difference here is I is going to go from 1 up to n. Does that make sense? Okay, so then everything in the sum is the same. 4 over n squared, I squared, plus 6 over n, plus 3, and then times 2 over n.
Quick question.
Yes.
Because we're only solving for ln, we don't have to. We just put ln equals all of that stuff. It doesn't have to be ln equals the limit because we're not finding the area or anything.
Right, exactly. So this right here is the approximation. So both of these are the approximations. This one and this one. So give whatever number you pick for n, the higher the value of n, the better the approximation. But to find the exact area, that's when you find the limit. So we're not going to find the exact area until part E. Does that make sense?
Yeah.
Okay. All right. Then to find, so then we can use these two formulas to find C and D, right? L4 and R4. Okay. So let's see here. So if I do part C, so L4 is going to be, so I'll just keep it in the same order. Now actually, since 2 over n, I'm going to multiply everything by 2 over n. Might as well just factor out the 2 over n. So here, is it okay if I do here, for example, 2 over 4? So this is my delta x. And then in here, so I'm going to have a big parentheses here. And I'm going to write, here I'm going to just have f of x sub 0 plus f of x sub 1 plus f of x sub 2 plus f of x sub 3. So I'm going to need quite a bit of space there, but so I'm just factoring out that delta x just so that you don't have, otherwise you would have a delta x in every term and then it gets pretty more messy than it already is, right? Because it's already pretty bad. Don't you guys agree? Okay. All right. So basically I'm going to take this right here, those three terms in that parentheses, I'm going to plug in 0, 1, 2, and 3, right? Okay, so what do I get when I plug in 0? So when you plug in 0, you get 0. So here you get 0, right? Plus 0 plus 3. So I have 3. Actually, why don't we do this? Let me pick a different color for each one. How about, okay. So this is going to be 3. So that's when I plug in 0. Then plus, I'm going to plug in 1. Again, you're plugging it into right here, right? So into the i's. Does that make sense? Okay, so what would I get if I plug in 1? Four over what? Not n squared. What is n? N is 4, right? Because we're doing 4 rectangles.
Wait, where do we plug in 1?
In for I, right? Because this is what we're doing, right? X, we're going to do f of x sub 0, f of x sub 1, f of x sub 2, f of x sub 3. What are those the little indices? Those are the i's, right? So it's the 0th x value, the 1st, 2nd, 3rd, 4th, right? So we're plugging 0, 1, 2, and 3 into I, here and here. Yes? Okay. All right. So 4 over 4 squared, right? Or 16. And then times 1 squared, right? Plus 6 over 4 times 1 plus 3. Does that make sense? So which one's that? That is f of x sub 1 right there. So if I color code this a little bit more. So the 3 was f of x sub 0, right? I plugged in 0 for I. That's why everything canceled out. And then, let's see. F of x sub 2. Now I'm going to plug in 2 for I, right? So what do I have? I have 4 over 4 squared, or 16 again, right? Times what? Times 2 squared, or 4, plus 6 over 4 times 2 plus 3. Does that make sense? Yes.
So on the first one, we did you replace I with 0, right?
Yes.
But n is 0 as well.
No, n is 4. But you have 0 divided by 4, which is 0.
Right, and then the 4n. But what about 6 over n? Wouldn't it give us like
Oh, you're right. Sorry. Yes, thank you. I don't know why I missed that. So this right here, so this should be 3 plus, shucks. Do you guys see that? Oh, wait, no. Sorry. No, it was fine, because there's an I right here, right? Oh, that's what it is. This is a typo. There should be an I right there.
okay.
Yeah, that's why. Sorry about that. Yeah, so I put it here, but then for some reason, I missed it down there. Yeah, sorry about that. Okay, so we're still good, right? Okay, let's see here. So now, let's see. I might need a little bit more room here. So let me get rid of that, all that stuff. Okay, so let's see. Okay, all right, plus, and then f of x sub 3. So what would that be? That would be 4 over 4 squared times 3 squared plus 6 over 4 times 3 plus 3, right? All right, so what's that? Okay, so this is equal to 12.25. Okay, so does that make sense? Any questions? Okay, now notice, let's see. So if I want to find R4, so obviously I don't have enough room here. But let's see. So, all right. So you guys try R4 later. So you should get 17.25. Does that make sense that the right would be more than the left?
Yes. You start with 1.
It does, right? So like notice if I draw the rectangle, so why don't we do this? So the left-hand approximation is going to look like this, right? Left, and then looks like that, and like that. So notice it's an underestimate, right? The left.
And
The
right hand's over.
right hand is going to be an overestimate, right? So the right looks like this in the purple. So I'll do purple like that. So see how now we're overestimating. We're going from 1 to 4. And then here. Like that.
So for the right hand
Uh-huh.
at for part G, we start at f of x sub 1 and go to f of x sub 4.
Yes, exactly. Yep. Yeah, so notice, so, I mean, basically you're going to have, so like if you look at it, you're not going to have the 3, so you get rid of the 3, but all of this you're still going to have. Every single one of these is going to be identical, and then you're going to have a plus at the end, plug in 4, and then whatever you get there. Yes?
Sorry, you guys are probably talking about it. I didn't hear, but for A, you have on top of the sum sign, you have n minus 1.
Yes.
The 4 will stay the 4 throughout the whole equation.
Right.
It's just saying if you look at it visually, it's before the end of the end.
Yeah, meaning that you're not going to evaluate the function at the very last endpoint.
Right.
You evaluate it only one before. That's the last one for the left.
Okay.
And then for the right, you do evaluate it at the very last one. Yeah? Okay. All right. Now, let's find the exact area. So let's open up a new one here. So how do I find the exact area? So the exact area. Okay, so if I write down the integral again, so I have the integral from 2 to 4 of x squared minus x plus 1 dx. So remember this right here. How do I interpret this integral right here? From last time, we said this represents the, at least temporarily for us, we know this as the area under the function, right? Area under the curve from x equals 2 to x equals 4, right? Okay. And what is that equal to? Well, it's equal to the limit as n goes to infinity of the sum from I equals, and remember we said it could be either one, left or right. But we'll use the right just because it'll be a little bit easier for us. So what would this be? This would be 4 over n squared I squared, right? Plus 6 over n I plus 3. Were they all pluses? I forget. Yeah, okay. All right. So then, so what is that equal to? Well, we need to do some simplifying, right? So let me just make a little bit more space here. So if I rewrite the sum, let's see. So 4 over n squared I squared plus 6 over n I plus 3. Okay, so what should be the first thing that I do? What sum rule should I use? Yeah, break them up, right? I do, yes. I forgot it, didn't I? Let me put it out here. 2 over n. 2 over n. And 2 over n. So I'll just factor it out of the whole thing then. Okay, so the first thing I should do is break up the sums into, in this case, 3 sums, right? Okay, so I'm going to have the sum from 1 to n of 4 over n squared I squared, right? Okay, plus the sum from I equals 1 to n of 6 over n times I plus the sum from I equals 1 to n of the number 3. Okay, so do you guys agree that? So I used the one of the sum laws that we talked about last time, right? And then what should I do? I can factor out the constants, right? Out of the sum. So here, let's see. So I have the limit as n goes to infinity of 2 over n. Now here I have 4 over n squared. I can factor that out of the sum, right? Does that make sense? Just factor out the 4 over n squared because it's a constant, right?
The n is considered constant.
Yeah, so make sure that, so yeah, that's a common confusion. Notice how, so n, the letter n, so this is important. So notice n is going to infinity here, right? But as far as, so it would not be okay to take the n and take it outside of the limit because n is going to infinity. But as far as the sum is concerned, this right here is a constant. So it is okay to take that out of the sum, but not out of the limit. Does that make sense? The difference between the two? So that's why you can take it out of the sum, because as far as the sum is concerned, it's a constant, and then it is going to infinity, but that's still okay. Yes. All right. So let me remove my scribbles here. Okay. So now what? So this is going to be plus 6 over n. So same thing, right? Factor out the 6 over n. And then I have the sum I equals 1 to n of I plus, and I'll just leave it. Yeah, it's 3. Okay, so then what is this equal to? This is equal to the limit as n goes to infinity of 2 over n times 4 over n squared. Okay, now this, what is that right there? So we need another sum law. So this one we didn't write it down last time, but let's write it down now. I'll put it up here in the corner. So the sum from I equals 1 to n of I squared is n times n plus 1. So that looks a little familiar, right? From last time. And then, but times 2n plus 1, and then divided by 6. So that's what the sum from 1 to n of I squared is. Yeah? So then I replace all that okay. And then what else? Plus 6 over n times, let's see, what is this sum going to be? N times n plus 1 over 2. Yep. All right, and then the last one, what's the sum from 1 to n of 3? 3n, right? 3n. Because that's just 3 plus 3 plus 3 plus 3n times, right? So
The n, the one in purple, and
Mhm.
that's similar to that idea. You just switch
right,
the I.
but that one we wrote down last time, right? So that's why I didn't write it down again, but I can. So this is the sum. Let's see. So the sum from I equals 1 to n of I. That's n times n plus 1 over 2. Okay, so, all right, so now we've got a mess, right? We have to simplify this. So let's see. Let's cancel some stuff out. How about, so any ideas? How about this n outside? If I distribute it, I can cancel it out with an n on each one of those. Is that okay? That sound like a good idea? So everything, if you distribute the n throughout, then as long as you distribute it on the whole thing, you're okay, right? And then what else can I reduce there? Anything? How about the 6 and the 2 is 3 and 1, right? Yep, the 4 and the 6 reduced to 2 and 3. Okay. All right. So then let's see. So this is equal to the limit as n goes to infinity. Here I'm going to have, so 2 times 2 is 4, right? And then what about all this stuff? What is all that? If I multiply all that out. Well, I'll do it in 2 steps. Why not? Okay, so what is that? That's going to be 2n squared plus 3n plus 1, right? And then that's divided by 3n squared. Plus, what else? 3n plus 3 over n. And then plus the number 3. Did I do that right? Or did I make a mistake? What do you say? I made a mistake. What is it? The 2. That's right. Alright. So it should be 2 times 3n and 2 times 3 and 2 times 3. Right? Where did that come from? The 2 that's on the outside, right? Does that make sense? Okay. So notice I'm getting the limit as n goes to infinity, and all there is a bunch of n's all over the place, right? So the easiest way to do this is to break everything up here. So like if I break everything up, if I distribute the 4 here, so here I'm going to get 8n squared divided by 3n squared, right? Okay. Plus 12n over 3n squared plus what? 4 over 3n squared, okay. Plus 6n over n. And then plus 6 over n plus 6. Okay, so notice a bunch of these go to 0. So let's see. Which one goes to 0?
12n over 3.
Yep. So n, 1n cancels out with 1, so there's 1n left on the bottom, so this is going to go to 0. What else?
4 over
This also goes to 0. What else? 6 over n also goes to 0, right? So what's left over is simply, so this is equal to 8/3 plus 6 plus 6, which is plus 12. So that's going to be what? 36/3 plus 8/3, which is 44/3. So this is the exact area, right? So what is that compared to the approximations that we got? So 44/3. What is that? That's
Closer to the right hand.
14 and something, right? And then if we look at what we had before here. So before we got 12.25 for the left, 17.25 for the right. So not very good approximations at all, right? Okay. So one of the big things that we kind of want to notice here is that this is pretty bad, right? I mean, we found the area, which is great. But wow, that was a lot of work just to find the area for that polynomial, and it was a quadratic. Imagine a cubic. You could do it, but it would be incredibly annoying. But you know, think of all the other functions, right? So you can only really use this technique so not only is it difficult, but you can only use it if the functions are pretty simple, right? So that's one of the big things that we're going to work towards is figuring out a way to find the exact area under the curve through other means. Yes.
What about finding a 5th-degree line?
Well, that would be terrible too. That would be more terrible. Okay, so any questions? No?